Thank you for joining us today and for talking a little bit about the courses that you teach here at Easter. You're a teacher within the engineering department, and you actually teach in two different tracks. So on the one hand, there's the energy and flow, and on the other hand, there's the sustainable materials. So let's talk a little bit about sustainable materials first. What is in the track? What do you cover? What are the courses like?
Yeah, so sustainable materials is partially material science, as the name already indicates. So this is really starting from the bottom up. So we start from atoms and molecules and chemical bondings and how they form crystals, and then how, because you can see from the small units how they influence the microscopic units, influence the macroscopic characteristic. So you can trace back all kinds of material characteristics, be it steel or polymers, to the molecular structure. And that's, yeah, so that is kind of the first course, which is called Structures and Properties. What I also include is a bit of strength of materials. So that is closer to, say, a physics course on mechanics, where you do, but it's in physics, what you generally do when you do mechanics is everything stays rigid. So there's no bending. For mechanical engineering, you need to think about what happens if you apply a force, because you do have some form of deformation, and that can very seriously influence your application. So that's also something that we do in that course. And then in the 200 level course, so the introductory course deals more with kind of simple structures, one dimension, and then in the 200 level we go full 3D. So basically we look at a more formal description of deformation. And we also do finite element analysis, which is kind of the method of choice to simulate actual behavior of parts and to find out where's the highest stress, where is most likely to break, these kind of things.
Okay. Now you also teach in a different track.
Yes.
And that's the energy and flow. So how does that come into all of this?
So you could kind of, both tracks are kind of mechanical engineering and chemical engineering, kind of a mixture a bit. And the energy and flow, on one hand, it covers thermodynamics, which is, it's just one of the most important courses, and I would recommend any student who's thinking about engineering taking thermodynamics, because you also need it for the 300 level sustainable material course. And you can use, thermodynamics is everywhere, to be honest. So whether you go into electronics or biology or also material science, you can explain it from a thermodynamic perspective. And then the 300 level course in that track is about renewable energy systems, which is basically my core research area. And I'm really looking forward to teaching that course in fall.
Right, I can imagine that you can have your real passion right there. Yeah. So what are some of the projects or the assignments that students work on in these kinds of courses?
Actually I brought an example. So we have basically when we talk about polymers, we have various machines. This is a thermoforming. We also have extrusion machines. So this is one of the lab exercises where students will just kind of work with polymers and how to process them. And this is just another example. So this is just waste plastic,
right,
brought into a new shape. So you can also be kind of artistic, of course. We have a gauge tester, so you do tensile strength testing. We have a grip tester where you use basically to look how does the material deform if you apply stress for a very long time. We're also using the electron microscope already in there to look at the surface of materials that have been broken. Because you can, from this surface or from the structure of the surface, you can determine whether it was, say, cut or bent until it broke. So it's also, of course, I mean, having a first year course where you already can work with the electron microscope is cool.
I think that's also what brings students in, right? That they get to do that hands-on
Yes,
practical exercise and
Yeah.
train their skills.
And it was one of the things that came back in the feedback from the students after we did the course, that they really enjoyed the practical part.
Mhm.
So I'm trying to include that, or continue to include that.
Fair enough. Now, of course, the courses don't just live in an engineering program, they live in a liberal arts and science program. So what are connections that you see students making, or that you are actively working towards with colleagues with other disciplines within our program?
So there is some of the connections are quite obvious. So one is from the material point of view with the biomedical department and science department. So there is one senior project coming up where we're looking at active biofilters together with, so that is in collaboration with the company as well. And I'm looking forward to that one. Then there is kind of a more, what I also like really about liberal arts and science and engineering is that you get artists and engineers to talk to each other, which is really hard. And I have, at the moment, for example, have an academic internship, and the student is looking at handmade paper out of recycled materials. And she's basically, so there's the personal preference of the artist, which type of paper you use for which technique. And she's trying to kind of translate that into qualitative parameters, so kind of what is the pore size that you, if you like this type of paper, then most likely because of these material characteristics, you like this type of paper for for another technique. So really kind of putting numbers in, which is I think very interesting as well.
Right. And how do, I don't know, some of them, maybe you mentioned the artists, but if you look at really sort of the tracks within UCR where your students are also taking courses, what are some of the ones that you think, oh yeah, that is expected, or some that are completely unexpected?
Well, expected ones would be, say, material science and chemistry. Sure. And yeah, I have students who do that. Others was a combination of physics, philosophy, and material science. So that was more unexpected. But that particular student found a really intriguing combination of kind of adding psychology to the mix as well, and kind of have these outer body experiences, and she somehow connected that to special relativity.
Right.
So I think that was very, very liberal arts and sciences to find that connection with. Yeah.
Right. And you've also taught in different places, so how are your classes here, having all these different perspectives coming in, different from, say, a regular material science course?
So far, to be honest, my classes were all much bigger. So I really enjoy the smaller class size because it gives you way more interaction. And I also feel that because students have more choice in which courses to take, that they're way more engaged with the topic. So just to give an example, the university I taught before, the program was really, really rigid. So students could take one optional course in the third year. And then that was a 5-year program. So fourth and fifth year gave them more options. But up until, so for the first 2.5 years, no choice. And then if you have to do this, and it might not be the branch that you're really interested in,
Yes.
So this is something that I have not encountered really here this year.
So there's an enthusiasm because
Yes.
students can really bring in their own interests, right?
Yes.
And build their skills and slowly figure out what they want.
Mm-hmm.
Right. Now, for any student considering material science or mechanical engineering, what would be your one advice?
It's a bit hard to say. So one is the logical thing. So you really need to know your maths. So, and it's also a certain aptitude. Like I think students who already started to take things apart and building them back together, and kind of the how does this work aptitude. So that would be students that I would say look into engineering.
All right. Well, I think students can understand that, you know, and understand whether this is for them or not.
Mm-hmm.
So thank you so much for taking me through something that for me is also quite new, and learning a little bit about the tracks and the courses has been great. So thank you very much.
You're very welcome.